Okay, so endangered species, we are starting, this is biodiversity video 4, we are starting on slide 71, we're going to go to about 91, and a lot of this is going to be a review for you guys. You've seen it before, so we're going to kind of talk about it in the environmental context. So extinctions have been happening for a long time. There have been mass extinction episodes caused by various things, there have been individual extinction episodes caused by various things. The difference now is that humans are having more of an impact. So for the first time, we're seeing a single species causing a huge extinction crisis globally, which has never happened before. Not only are we causing more than one species to become extinct, we're also making it happen faster than ever has happened before. And one of the reasons this is such a big problem is that not only as humans are we having an impact on individual species. For example, we overhunted and killed all the buffalo. But now we also are eliminating the whole ecosystem, the whole environment. So for example, if we continue to cut down the tropical rainforest, we're going to end up without having all of the species within that tropical rainforest. All of those species are going to become extinct, and that is what's causing the whole crisis as opposed to individual species. A lot of vocab you guys already know. You guys can pause this and write it down. Make sure you know extinct. What you may or may not know is the different levels of extinction. A local extinction is one that's found where it is no longer found in a specific area, but it's still elsewhere in the world. We're seeing that a lot where you see the home range of an individual species has shrunk dramatically. So that is a local extinction. It's not found in one place, but it's still found in the world. An ecological extinction is also happening a lot. The buffalo is a great example of that. Buffalo are not extinct. However, it really essentially is an ecological extinction, or was for a long time, because so many of them were gone that the few that were left didn't really have any sort of impact on their ecosystem. They didn't impact the food web anymore. They didn't compete with other species for those resources. So essentially they were taken out of that food chain and out of that food web for all intents and purposes. And that's an ecological extinction. A global extinction is the one that you're probably most familiar with. That's where there is simply none of those species left again. Some of the species here, again, just to give you guys some examples, you guys can read them for yourselves. Human activities. Notice that a lot of these birds were, 3 out of the 5 were flightless birds, and so really easy to hunt them down, and they were delicious. And so this was a case of an extinction from a single issue from overhunting. Endangered and threatened species. These are what we call the smoke alarms. You know already what the definitions are, but what makes these important is that they're kind of the warning. They're the oh, we need to take notice of this, to be aware of this, because now if this species is declining, if we're seeing fewer and fewer of these species, there must be something going on. We must be having some kind of impact. So hopefully if we notice stuff like this and take steps to prevent it, then they will not only not become extinct, but their whole ecosystem will remain healthy because we fixed whatever that problem was. So some of the examples of that are all of the above. The Florida manatee is a great example. It became a big indicator of species where boat strikes were just demolishing the population. Huge loss in numbers because motorboats were hitting them. So now there are speed laws, so you can see them before you hit them. You have to move slowly through specific areas where they like to graze, and so their numbers are slowly starting to come back up. African elephant is still really touchy because there's an illegal trade going on that's very dramatic right now. We'll talk about that a little bit later. The same for the tigers, and then some of those smaller ones, it's not necessarily, the smaller species, it's not really as easy to see what the problem is in order to fix it. So the stuff like the cactus and the prairie dog, you can name a whole bunch of possible causes and try preservation, but it's not necessarily always as directly easy to see. If I stop this population will return. More examples. The examples on this slide are a lot of the hopefully the more well-known ones. Hopefully you guys have heard of at least some of these where they've gotten a lot of press coverage, a lot of attention drawn to the problem, the overhunting, the loss of habitat, like with the sea turtle, the pollution in the ocean, and the sea turtles are getting sick, stuff like that, where public awareness has helped to bring attention to the problem and therefore cause a solution. We talked already about endangered. Another example is a leopard. Leopards are endangered worldwide right now. The threatened and vulnerable, the northern or Steller she lion is a threatened species right now, and that's actually the one that my husband is doing his dissertation on. So he will probably come in and talk to you guys about his research in the spring. A rare species is one that we're noticing a decline. It's not quite to the threatened stage yet, but is definitely an issue. Okay, so restoration is trying to bring it back to the original state. Rehabilitation is returning an ecosystem back to a functional ecosystem, and replacement is exactly what it sounds like, returning or replacing the problem one with a new type that might be a better fit. Artificial ecosystems are happening more and more where we can't really replace it, but with a natural one it would take too long, so we're replacing it with artificial. We're kind of giving it a jump start. Artificial wetlands, where we're planting the wetland plants and allowing everything else to congregate from there. Artificial coral reefs, where we're sinking a ship or something on purpose to allow the coral to build on that reef and create a new reef. All of those are artificial ecosystems. And we're using them to help with the problems, and we're making them a little bit faster than nature would do on its own. So there's 5 principles that you want to kind of take into account when you're working on restoration. You want to know the cause, what's causing the problem. You want to stop that cause, and then you want to reintroduce species, protect the area, and then manage that area. So those are kind of the 5 steps that scientists use in restoration. There's becoming an increasing problem or increasing awareness that as restoration builds in popularity, there's this thought process where, I don't have to worry about destroying this habitat because we'll just restore it after the fact. And so that kind of mindset is something that should be really strongly discouraged, simply because if you can't make the argument that you don't want to kill those animals, you don't, so on and so forth, the argument that it's cheaper to prevent than to restore seems to be the only one that will work on some people. Mitigation costs are the costs that it's going to take to restore something, to fix all the problems, to create a solution. So what will I have to pay the loggers in order to stop logging? What will I have to do to move an endangered species to a new habitat, or to restore this area, to rebuild this, to change this pollution pattern, stuff like that. I already talked about restoration. Preservation is setting aside undisturbed areas, so you can't fish on it, you can't hunt on it, you can't build a house on it, you can't XYZ, whatever the case may be, in order to keep that area as natural as possible. Remediation is repairing it, and the sustainability is how long will it survive. What can we do? Protecting biodiversity, is you guys could probably, again, this is really common sense. Take action to preserve those hot spots. Take action to preserve the old growth forests. Continue mapping the biodiversity and the decision making for the decision making. So whereas we see a lot of these policymakers, lawmakers, government leaders trying to make decisions on where to allow people to hunt and how much of these resources should they take, they need scientists who have done the research saying, yes, it's okay to take this, no, it's not okay to take this. And so we need that inventory and decision-making data. So there's a strong need for biologists. A lot of people go, why is it important to go discover new species? What does it matter? This is why it matters. We need to be able to make the decisions. The world's oceans are hurting. They need attention really bad right now. We don't know where the hot spots are. We don't know where the resources, all of the resources are. There's maybe 1% of the ocean floor that's been explored right now. I mean, we just discovered a new whale species, like, I don't know, 6 years ago. So there's so much we don't know about the marine ecosystems that is somewhere that we really need to focus a special effort on. And then on land, we really need to focus on the aquatic ecosystems. Those are the most threatened for a number of reasons. Those are the ones that have the most pollution going through them, because it's the water movement that facilitates pollution movement. And then on top of that, people need water, so that's where most of the people are going to live. So that means that they're the most threatened, they're the most polluted. So we need to work on those as well. Make sure when we work on a global conservation strategy that we have all of the ecosystems represented. And then this making conservation profitable is a really key concept. So it's a simple statement of fact, unfortunately, that right now, in a lot of cases, it's getting better, but in a lot of cases, it's cheaper to use the resources that are not environmentally friendly. It's cheaper to drive, and I'm as guilty as anybody else, it's cheaper to drive the gas car. It's cheaper to not recycle, to just throw stuff out. It's easier, it's simpler. So we really need to make conservation profitable. We need to make it easier, we need to make jobs from it, we need to make people want to do it. And once it's profitable, once it's easy and cheaper for them to do that, the problems will take care of themselves. Okay, I know I said we'd stop, but this is pretty short, so we're going to keep going. So species extinction, some species are vulnerable to extinction more so than others because they have specific characteristics that make them valuable to us, or make them sensitive to changes in their environment. So for example, stuff like low reproductive rates, specialized ecosystems, relatively small distribution, the upper level species, migratory patterns that get in the way of our movements, and then definitely the commercially valuable, the ones that we want, and then large territories where we want some of that space. All of these are characteristics with examples of the animals that you could say, oh right, well, if you kill a blue whale, then it's going to take another 30 or 40 years for that blue whale to be replaced because they reproduce so slow. Or if you kill off all the elephant seals, or you destroy this one habitat, there's only so many elephant seals and there's nowhere else for them to go. The same thing for the polar bears. The topic of the trophic levels, we've talked about that top-down control already. Migratory patterns were getting in the way of the routes that these animals take, and so they're not surviving as well because they're not able to move around us. Stuff like that. Okay, this is all stuff I've talked about. What I have not talked about, preys on livestock or people. A lot of the times it's really hard to get a farmer to protect a wolf, an endangered wolf species, when the wolf is eating his cows or his sheep or whatever. So stuff like that. Behavioral patterns where an animal needs X amount of land to roam a territory, or needs this amount of privacy in order to reproduce, or stuff like that, when we're infringing on their territory, that makes things harder and harder. So we use a whole bunch of stuff to estimate the rate of extinction. Every year, the International Union for the Conservation of Nature and Natural Resources publishes their red list, and that looks at the world's threatened species. There are over 15,000 species in 2004. Looking at the demographics of those species, fish are by far, like I said, those freshwater species are just getting hit so hard with pollution and loss of habitat. Mammals are up there because they tend to be that top-down control. They tend to be the top of their ecosystem. And then we see representatives from all the rest of the groups. Okay, so habitat loss and degradation. The phrase that I want you guys to remember to help you remember what causes extinction is HIPPO. So habitat destruction, invasive species, population growth, pollution, and overharvest. Those are the 5 causes of extinction, all summed up. Causes of endangerment, habitat loss. People are moving in and out, and so that's one of the biggest reasons that we're infringing on those ecosystems. The polluted air, polluted water, all of the pollution causes are a loss of habitat as well to these animals. The overhunting, on individual species, overharvest of individual species, all of those, the species that we eat, that we use for profit, all of those is a problem. So in the U.S., the big areas, kind of hotspots for species being endangered, California, Hawaii, Texas, and the southeastern states like Florida. These are all the areas where we're seeing lots of endangered species, where we're seeing lots of pollution, where we're seeing lots of habitat loss, and these are the problem areas. Worldwide, the problems comes where there's lots of poaching, and the developing countries, and the developing countries are just not worried about endangering animals because they're just concerned with keeping themselves alive. So those developing countries are, I think about it, if you were starving, you would eat an endangered animal because that would keep you alive. So it's that concept where, and I'm not saying that's wrong, where we just have to help them fix their problems so they can take into account the global problems. So conservation biology is the science that looks at diversity, looks at how to maintain the Earth's ecosystems. This is an incredibly fast-growing job market is increasing. Colleges are starting to offer programs in this. I just actually got a flyer, remind me to show you guys about a new program in conservation biology where you're looking at all, because it's not just going out and studying the animals. You have to know the animals, you have to know about the resources and the natural stuff, and then you also have to know about the policy and the lawmakers and be able to work with governments and diplomats and try and make these decisions. So it's kind of this 3-pronged approach that can get really complicated and challenging. Looking at in situ versus ex situ control of an endangered species. And in situ control leaves the animal where it is and protects it. So elephants. Elephants are endangered. We haven't taken them anywhere. We've left them where they are. We've put poaching laws in place, and we're trying to have people enforce that. We haven't taken the marine turtles anywhere. We're leaving them in the oceans, but the nets that need to be used now have to be able to have a turtle escape mechanism so they can't drown. So we're leaving that animal where it lives in its natural habitat, but we're taking preventative measures to fix the problem and protect that species. And ex situ is to remove it from the habitat. So essentially you're going to take the animal out of where it's supposed to live and put it in a zoo. You can 2 types. You can take the eggs, the young, and collect them and then hatch them in zoos or research centers and keep the animals essentially in captivity or in controlled areas where we can watch them and make sure that that species doesn't become extinct. And then captive breeding is the other option as far as continuing that species in an ex situ situation. Okay, so looking at some of these species, we have the Indian tiger. 100 years ago, you saw a huge range. I mean, they were everywhere. There's only about 2,300 left today, and you can see much, much smaller range. So this would be like an ecological extinction. Their range is significantly smaller. They're not found in all areas they used to be found. The black rhino, same thing. There's about 3,600 left today. A couple hundred years ago, huge range. Same for the African elephant. The Asian or Indian elephant, same thing. More individuals of these left, but significantly smaller range. And I think we're going to